This session is going to be about, it's called Moving Fast with Serverless Applications. I'd like to start with a question. How many of you have an experience with serverless? Already developed something with serverless? Cool. And how many of you using Amazon, AWS? Moving fast in serverless, what does it mean? I mean, serverless is built for moving fast. I mean, have auto-scaling, it have managed resources, so you don't really need to deal with it. So when I'm talking about moving fast in serverless, what do I mean? Well, when I talk to regular, to my friends in startups, and I telling them about all the wonders of serverless, like zero configuration and auto-scaling, they say like, yeah, but I have auto-scaling already. I mean, I have like people in my company that their job is to, they see their job is to configure all these servers and to manage all the resources. So they sit in front of their black screens and do their thing. So I'm, as a developer, just write my code and hit the button in Jenkins and deploy it. So why I need this? Why I need serverless? The situation is different for small startups, for people that don't have human resources to deal with the configuration. But they struggle with another problem. The learning curve in serverless is pretty steep, and there's not so much information about the development process and tutorials how to start with serverless still. It's going to be fixed. And actually, the development process, like starting with serverless, is super hard. Not because of basically because of the testing and monitoring and debugging your application. You can do it locally. So your development process is development time increases. But once you overcome these obstacles, you're gonna be like you're gonna be unbeatable. You're gonna be like badass developer. And you can develop any kinds of applications super quick. But you still have one problem, and you can't fix it. Can you guess what? How to explain to your non-tech friends what is serverless? It's like, you're going to conference in London and going to speak about, what are you going to speak about? So like, it used to be servers and now there's no servers. Oh, cool, wonderful. Is it good for environment? Yeah, could be. So, how to move fast with serverless? How do we develop habits and environment that allow us to develop quickly and deploy our application and be able to find bugs in production quickly so we can fix it fast. A few words about me: software engineer, a fresh father for a 5-month-old boy. Previously worked on in Fiverr and other companies. Most of the time deal with microservices and check for putting embarrassing photo on the conference talk. I work at Epsagon. Epsagon is a service monitoring tool, which sounds a bit boring, but there's a lot of action in monitoring service application, believe me. I'll have some examples. So some dry data, we 100% serverless. We have more than 200 lambdas in productions, and we use our product to monitor ourselves. So sometimes it saves our assets. And we recently launched a self-service product. So how to move fast with serverless? again. Let's break out the development process into 4 stages. It's design and research, development, QA, and monitoring. We're going to fix how we develop fast, how we debug our application, and how we detect bugs in production quickly, so it don't have any effect on, how we reduce the effect on the end user in our application. Let's start from development. Well, the transition from the regular stack, I will call it, to serverless is that you used to have all these resources, just like Mongo, MySQL, Postgres, Redis, and just by accident it's only databases, but there are many others, and you can run it locally. Like every single service you can run on your machine, and you can reproduce any flow in your system pretty easy. So you can just put debugger in your code. You can, I don't know, use Postman to send a request and then catch it in a breakpoint and write your code just in a console and just put it to write the whole function locally. So in serverless, you have the managed resources instead. So instead of all these databases, you have Dynamo, you have SQS, which is queue management system, SNS, which is Amazon notification system, and many others. And you can't run it, locally. So basically, the only way to test if your code works is to deploy it to cloud and run the whole thing in the cloud. And I just want to show. I want to start a simple example. This is a simple licensing system for desktop application that I built for myself. What's going on here? So we have an external service. It can be a payment system. It can be Stripe. It can be PayPal or any other system. So when user pays for the application, there is a webhook that go to API gateway, and it invoke Lambda. And no. So it's invoke the Lambda, and Lambda verify the signature of the request, and it generate a license key, save it in DynamoDB. Then from other point, we have another Lambda that subscribe to DynamoDB events, and just once I have a new key in DynamoDB, so I generate an email template and I send it to a user with the instruction and with the license key. This flow, like the API gateway to the Lambda to DynamoDB, you can reproduce it locally, pretty easy. But what about the event? What about Lambdas that are triggered by DynamoDB? It's impossible because you don't have Lambda, because you don't have DynamoDB running locally. So this is how your development process looks like, the regular one. Is anybody familiar with serverless framework? So for those who know, if you're planning to start with serverless, I really suggest you to start with this one because it's, in my opinion, it's the easiest way and do all the heavy lifting for you. So you write your code, then you say, okay, it should work. Then you deploy it, and deployment takes some time. So it upload the CloudFormation configuration to S3. Then it pack your code with all dependencies and the zip file and upload it to S3 as well. Do some other things. And during this time, I mean, you don't see in front of computer, so you, with some use, you have some context switch. You go grab some coffee and stuff. So, and now, when you recall that you have your code deployed, you test it and it failed. So, okay, so you look into your code and you find a bug, and then you fix it and say, okay, this time it's going to work. And you deploy again, you spend another 15 minutes, you talk to your coworkers, you grab some coffee, Facebook, and then you fail again. You say, okay, so this time, now I know what's the problem exactly, so this time I'm going to work for sure. And you have the same trap again. You do the same thing again, you deploy, and then the day is over, so you go home and you continue tomorrow. And development time increases. So ideally, what would be an alternative for this one? So ideally, you would be able to run the whole application locally, but sometimes it's not impossible. It's not possible. If we take for example, the event that the lambda that invoked by DynamoDB, then there are some tools that you can actually generate this event locally and be able to test it locally. It's called SAM, developed by Amazon. It's open source. So it has a nice feature to generate an event locally, like, for example, S3 put event or DynamoDB event. And this is how the output looks like. So I'm going to show you a quick example how you can use this to make all the tests, to make all debugging locally. Now you can see it. And you see, you can generate just any kind of events. And your machine can be Cognito, S3, SES, SNS, SQS. So if I take, for example, DynamoDB, so just do DynamoDB. And there are some events, like we have a table update. And this is the payload of the event. So how can you use it? I'll show you a quick example. So in SLS, you have a plugin so I'm just going to write a quick test, okay? Create a new function. Oh, okay. Never mind. So basically, I just wanted to show you, how can you just quickly run a test, and you can wrap this SAM library with just really minimal code that just generate any kind of event for you, and you can pass it to your Lambda, and you can test locally Lambda before you deploy it. So in a cloud, you will focus on debugging more complex issues. So I said before that there is no way to run DynamoDB and S3 locally. But actually there is a library called LocalStack. Anybody familiar with that? So actually you can kind of simulate manage resources locally. The tips and tricks part is over. Let's move to the next phase. So the next phase is monitoring, and you may ask how monitoring connected to moving fast. And maybe Zach Zuckerberg have an answer for that. So move fast and break things. Unless you are breaking stuff, you are not moving fast enough. And in startup, no matter how many tests you're going to write and how how much you're going to test your application, you will always have bugs. So you have 3 options to deal with it. The first option, just write a good code without bugs. Just stop putting bugs in your code, which usually don't work. Another option is, so you can invest even more time in testing, in QA your code, write more integration tests and staging tests. But there are 2 cons of this approach. You will have more code to manage. You will have bugs in test as well. And your development process will be much heavier. So the third option is to have some tools that will give you confidence to deploy your code to production and be able to find bugs really quickly after you deploy the code. But the truth is somewhere in between those 2 approaches. I mean, you still need to have some integration tests and unit tests, and you need to check your code before you deploy. But you don't need to focus only on this. You do need some good monitoring tools to give you confidence after you break stuff, be able to find bugs quickly. Monitoring. Monitoring is not using every system have it. You use it to track system health. Use it to discover and fix issues. For example, if I develop a new feature in sign-up flow, and I deploy it, and then I monitor my flow, and I see that sign-ups in a big scale, usually at this time of the day, I have 1,000 sign-ups, and after my deploy, I have 500. So maybe if in my feature I have some silly JavaScript validation bug that caused this issue. So using monitoring tool, I can very quickly find it and fix. And optimization, performance, and cost. Well, it's always time for improvement, no matter if you how good is your application, you still can improve your user experience, the loading time, and something that's pretty unique for serverless is cost. You can monitor your cost spikes and fix issues related to cost. So let's just talk about serverless application. What is serverless applications? And if serverless is just about focusing on lambdas, is focusing on writing your code and deploy to cloud and it just works. So the ideal serverless application, you will use as much managed resources and external APIs as possible. So you will outsource your business logic, for example, Auth0, Twilio, Stripe. Instead of developing it yourself, you'll make integration between the application. For example, your MailChimp sign-up form that put things straight to Salesforce, things like that. So this is an example of real serverless application. And you see, your system is not just your lambdas. So what happens if we have a bug in a lambda? First of all, nobody will tell you to. You will just somehow discover it in your system. Like when you see your monitoring graph, so you see you have a bug here. So you open a CloudWatch, and here's all the logs of this lambda. And now you need to find where there was a bug. It can be some edge case that happened at 4 a.m. and now it's 8 a.m. at your work and try to figure out what was the problem there, what was broken. So good luck with that. I mean, so you scan the log and you understand that nothing wrong with this lambda specifically, everything okay. But what really happened, it was, the problem is another lambda that triggered this lambda. So you do the same process again for another lambda, and you do it once or twice, and you will quickly understand that you can't look at lambda as a standalone component. It always always a chain of components. There are always some data flows. So this is how you should look at your system. And being able to take those asynchronic events and connect it together is what's called distributed tracing. So here's another example. I have a bug in this component. By the way, this is what Hexagon generate for you once you put our instrument your lambdas with Hexagon. So it's know how to draw your entire application. So you have a bug in this lambda, and it's something division by 0 error. So the lambda is okay, nothing wrong with it, but what caused it was SNS event. So you get to the payload of the event, and nothing wrong here, so you go back to lambda that published to SNS, and everything looks fine, but you see that you have failed to authenticate user. So the bug that happened in this lambda was caught, but something very far away from this lambda. And this is pretty common in serverless applications, because even small applications have many components. There is another issue. In serverless, time is money, which means that you pay for your runtime, and you pay for when you wait for an external service to respond to you. So if it takes too much time for Stripe to respond to you, you pay for this time. And being able to understand the interaction between those components is very critical in serverless applications. So this is the real life example. In the early days of Hexagon, we was looking for a way to scan CloudWatch and to take and to process all the logs from our clients' lambdas. So this is a solution we came with. We just found the same lambda multiple times. Every lambda was going to another part of the log and processing it. So it's pretty easy. And then we saved it to our RDS for further calculations. So it's pretty easy. And a week before, we deployed a feature that estimates the cost of every data flow. So when we deployed this one, actually, in the evening of the same day, our CEO sent a WhatsApp message to a CTO saying, "Is it real?" And he pointed to this estimated monthly cost, which is $12,000 for a single lambda. And of course, it was like, holy shit, what we did. So what really happened? So we started many lambdas. We started about 5K lambdas to scan different parts of the CloudWatch, and the CloudWatch became highly throated, and the CloudWatch allows only 5 concurrent connections. It means we have 5 lambdas scanning the log, and 5,000 lambdas waiting for their waiting in the queue to connect to the CloudWatch. So we ended up having 5,000 concurrent lambdas for 5 minutes, every 5 minutes. And so the cost was just an estimation. I mean, if we was lucky that we was able to see it really quickly and stop this. So the solution was, instead of pulling logs from CloudWatch, we just subscribed to events from CloudWatch. So just CloudWatch pushed event to our Kinesis, and then we did all the calculation later. Here's another example. So this is just simple data flow in a blog. So you have an API gateway. You have a post endpoint for a new post, and it invoke a Lambda that that just authenticate the user and publish the event to SNS, then go to another Lambda, and so on. It's not really interesting, but what is interesting is this external service took us almost 1 second. And it's okay when it's only when a single transaction, but if you have thousands of these transactions in a day, you're going to pay a lot of money. Summing up, so we talked about development process, and I mentioned tests, and I'm not going to tell you that my point is not that you have to write tests. I mean, everybody knows this, but my point is that writing tests in serverless specifically can save you a lot of time of development. And be confident and find a tool so you can be confident to break things in production and fix it really quickly. Thank you.